Hi, and welcome to this new video in the series on Bluetooth Low Energy technology. My name is Mohammed Afani, and in today's video we'll be covering security as a follow-up to the previous video on the topic. Some of the topics we'll address in this video include a comparison between the different versions of BLE in terms of security, which covers the topic of LE legacy connections pairing as well as LE secure connections pairing. Then we'll go over better understanding what triggers security in terms of how to secure your BLE application. And finally, we'll cover the topic of privacy in BLE. Let's revisit the security phases in BLE. Here's the sequence diagram we went over in the previous video. The first two phases, as we mentioned before, make up the pairing process, and the third phase is the phase of bonding between the two devices. Now in this video, we'll be getting into each of these phases in a bit more detail. In BLE, the security processes and pairing methods differ based on which version you are using. First, we have what's called legacy connections. These are supported by all versions of BLE, starting from 4.0 up to Bluetooth 5. And in this type of pairing, a short-term key, or STK for short, is generated from a temporary key, or TK, that is agreed upon or entered by the user at each of the two connected devices. The STK is then used for encrypting that connection between those two devices. Then we also have what's called secure connections. These were introduced in Bluetooth version 4.2, and in this case a long-term key gets generated from each device's public key that gets transmitted over the air from each side. This LTK is then used to encrypt the connection between the two devices. Now for each of these, a pairing method gets used, and the pairing method defines the processes and the data exchanged between the devices in order to secure the connection. Now the pairing method that gets used is determined based on the features exchanged between the two devices in phase 1 of the security procedure. Now before we get into the different pairing methods, let's take a look at some of the features that get exchanged between the two devices during the phase 1. Here are the features that get exchanged between the two devices during phase 1 and include the following: I/O capabilities for the devices such as the existence of a display, a keyboard, or yes and no keys, the out-of-band flag, as well as authentication requirements. Some of these authentication requirements include whether bonding is requested or not, also whether man-in-the-middle protection is requested, as well as the support of secure connections. And finally, we have the maximum encryption key size and which keys to be distributed between the two devices. Let's take a look at the different pairing methods used in both legacy connections pairing as well as secure connections pairing. Now in legacy connections pairing, there are three pairing methods. First, we have the just works, which is the least secure of all methods and uses a predefined TK set to 0. Then we also have the out-of-band. In this method, the TK is exchanged between the two devices over a technology other than BLE, with NFC being the main one. This method can make the pairing process much more secure, especially if the non-BLE technology used provides stronger security. And lastly, we have the passkey method. In the passkey method, the TK is a 6-digit number that is transferred between the devices by the end user, for example by entering it manually into one of the devices. The challenge here is that the devices need to have some minimal UI capabilities such as a display and keyboard entry methods, so its use may be limited. In secure connections pairing, on the other hand, we do not have a temporary key or a short-term key, but rather each device creates their own private public key pair and then sends their public key to their peer. Here are the pairing methods that are used in secure connections pairing. First, we have the just works, and in this method the public keys for each device along with other generated values get exchanged between the two devices over BLE. Then we have the out-of-band, which is similar to the method used in legacy connections pairing, but rather the public keys are exchanged instead of the temporary key over a medium other than BLE. The third method is the passkey method, and in this method, a 6-digit number is entered by the user into each device, or one of the devices will generate it for the user to manually enter it into the other one. The fourth and last one is the numeric comparison method. Now this method works the same as the just works method described previously, but adds an extra step at the end which allows protection from man-in-the-middle attacks. This is by far the most secure of all the pairing methods. Now let's look at how the pairing method used in phase 2 in the security process is determined. First, the secure connections is used only if it's supported by both devices, so if the secure connections flag is not set by one of the devices, it will not be used for securing this connection. In the case of legacy pairing, the out-of-band method is used only if both devices have the out-of-band flag set. However, in the case of secure connections, the out-of-band method gets used if at least one of the devices has the out-of-band flag set. If both devices have not set the man-in-the-middle protection option in the authentication requirements flags, then the I/O capabilities will get ignored and the just works method gets used. Otherwise, if either of these devices has the man-in-the-middle protection set, then the I/O capabilities are used. Here's a table taken from the Bluetooth specification document. The table is split into two parts and maps the I/O capabilities to the pairing method that gets used. For example, if the initiator has a keyboard and no display, listed here as keyboard only, and the responder has a keyboard and display, then the passkey entry is used. The responder displays the passkey while the initiator inputs the passkey. In this case, the connection is considered authenticated. Distribution of keys, or phase 3 of the security procedure, only occurs if the two devices request bonding, via the bonding flag that's set in the feature exchange messages that occur in phase 1. Now in legacy connections pairing, as well as secure connections pairing, there are two keys that get distributed. The IRK, which is the identity resolving key, as well as the CSRK, the connection signature resolving key. In the case of legacy connections pairing, there are three other values that get distributed. These include the long-term key, or LTK, the EDIV, or encrypted diversifier, as well as the random number, or RAND for short. Now that we've covered the details of each of the phases of the security procedure, let's understand how security is triggered. There are four cases that trigger the security procedure. First, a slave may send a security request to the master, to which the master may respond with a pairing request. This triggers the slave sending a pairing response message. The master may send this pairing request message without a security request coming from the slave in the first place. The third case is when a client accesses a characteristic that requires security. And the last case is when two previously bonded devices reconnect with each other. This is more of a simplistic view of the security triggers. There are more details related to the different security levels as well as modes, and to learn more about those, refer to the official Bluetooth specification document. Privacy is another major concern for users, and it has to be taken seriously. Each Bluetooth device has an address, and if no careful measures are put in place, this address can be used to track users. Fortunately, BLE provides a privacy feature to safeguard against such vulnerabilities. Privacy is addressed in BLE via a frequently changing private address of the Bluetooth device. Now, only trusted devices will be able to resolve these random private addresses, and a trusted device in this case is the bonded device. The random private address is generated using a key called the identity resolving key, or IRK, and the peer device uses the same key, the IRK, to resolve the random private address. The IRK is exchanged between two bonded devices during the last phase, phase 3 of the security process. In the next video, we'll cover the topic of Bluetooth 5 and IoT. We'll talk about the important role of Bluetooth 5 in the Internet of Things, or IoT applications. We'll also cover some of the features that were included in Bluetooth 5 that facilitate IoT applications. And lastly, we'll compare with other technologies that compete with it in the space in the field of IoT.
To learn more about Elysis, provider of the world's most advanced Bluetooth analyzers, visit elysis.com. Have a need for training or consulting services? Then contact our training partner, NovelBits, at novelbits.io. I hope you've enjoyed watching this video and learned a little bit more about BLE. Thank you for watching, and I'll see you in the next one.